Hybrid surge tanks are closed surge tanks which include an air vent. This air vent will open when the pressure in the tank drops below atmospheric pressure during a downsurge, or under general low pressure conditions. For this reason, hybrid surge tanks are often used in systems with low operating pressures. There are two basic hybrid tank variations. First is a hybrid tank with an air compressor. The air compressor is used to maintain the desired air pressure under normal operating conditions while the air vent is closed. The air vent will open when pressure equals 0. The second is a hybrid tank variation called a dipping tube. The tube is on the interior of the tank and connects to the vent at the top of the tank. As the liquid level falls below the bottom of the tube, the vent opens and air in the tank is replenished. As the liquid level rises to the bottom of the tube, a seal is created and the air outside the tube is compressed. Liquid rises within the tube until the air vent closes. This type of surge tank does not require a compressor. The length of the tube can be varied to control the air volume. When a regular hybrid tank is first brought online, the tank will initially be filled entirely with air. As the pump turns on, the pipeline is filled and the water column rises, and the air becomes compressed. A compressor is used to maintain the exact desired air pressure within the tank. When a surge event happens, such as a pump trip, the air volume expands and the liquid level drops. Once the pressure equals 0, the vent opens and air begins to enter the tank. When the pressure wave is reflected and the upsurge begins, the liquid level and the pressure rise and the vent closes. The air is compressed within the tank. When a dipping tube is first brought online and the tank is initially empty, the liquid level will rise until it reaches the bottom of the tube. At this time, the air outside the tube begins to be compressed with isothermal compression, and the liquid column rises within the tube and closes the vent. When a surge event happens, such as a pump trip, the air volume expands and the liquid level reaches the bottom of the tube and the pressure equals 0. The vent opens and air is admitted into the tank. When the pressure wave is reflected and the upsurge begins, the liquid level rises to the bottom of the tube and the vent closes. Air is compressed within the tank. Expansion and compression are isentropic. To model a hybrid tank within surge, a closed surge tank node is used. Check the hybrid box. Once the hybrid box is checked, the initial gas volume now takes on a different meaning than it has for a regular closed surge tank. The meaning also depends on whether the Calculate Initial Level option is selected. If Calculate Initial Level is selected, then the initial gas volume is the volume of air when the pressure equals 0, which means just as the vent opens. For a dipping tube, this is also when the liquid level is at the bottom of the tube. This is the recommended approach. If Calculate Initial Level is not checked, then an initial level must be input and the initial gas volume becomes the initial compressed air volume under a pressure greater than 0. The gas volume at pressure 0 will be calculated by the software. It is assumed that the air vent in the tank is large enough for unobstructed flow. For this reason, there is no input for the vent characteristics in the model. One of the inputs for all types of closed surge tanks is the expansion constant. A value of 1 means expansion is isothermal, and a value of 1.4 means expansion is adiabatic. Typically, a value of 1.2 is used. However, some assumptions about expansion are made with hybrid surge tanks in particular. It is assumed that the initial filling of the hybrid tank is an isothermal process, and that expansion constant will equal 1 during that process. The filling of the tank is assumed to take place slowly, and it is assumed that heat is allowed to dissipate to the surroundings. The initial air volume is calculated by Boyle's law based on this assumption, where P is pressure, V is volume, and the expansion constant is N. In this case, N equals 1. If the expansion constant input by the user for the tank data equals 1, and all expansion and compression is isothermal, then this means that during a down surge, the compressed volume will expand to exactly the initial volume when the pressure equals 0. If the expansion constant input for the tank is greater than 1, which is a common input, then the expanded volume when pressure equals 0 will actually end up being slightly less than the initial air volume. Now let's look at a couple of examples. Here is a model with a hybrid surge tank already set up. There is device help here with information about units, geometry, and general definitions. This device help includes many of the diagrams displayed in this video. You can click the next button to access those diagrams or click on them directly here in the contents table. For more detail on inputs such as inflow and outflow resistance and other input data not discussed in this video, please see the video called Adding and Sizing a Closed Surge Tank or use the Device Help button. As you can see, the hybrid option is selected along with the Calculate Initial Level option, which is the recommended setup. When we analyze the model and view the pressure graph, we can easily see the moment when the vent opens and the internal and external pressure become roughly equal. The vent opens at around time 27 seconds, then closes at around time 95 seconds. Within the report, there is a section called Tabulated Results. We can see an indication of this vent opening and closing by scrolling down to the corresponding times we observed in the graph. So if we go to about time 27, we see that the hybrid tank switched to an open tank. And it's worth noting that when a hybrid tank vent is open, the tank is treated like an open surge tank, and when the vent is closed, it is treated like a closed surge tank. So we'll scroll down to the time at which the vent is closing, about 95 seconds, and we see here that the hybrid tank is switched to a closed tank at time 95.78. Here's our second model with a slightly different response. As the air volume expands and the vent opens, at this point the hybrid tank, as we mentioned, begins to be treated like an open surge tank, and the pressure is determined by the head of the liquid level within the tank. This particular tank also has an elevation difference of 3 meters. So back to the graph. The external pressure when the vent opens jumps to match these open tank conditions. It takes a few seconds, but eventually the pressure within the tank and the pressure within the pipeline become equal. Then the liquid level increases eventually until the vent closes. About 18 seconds later, the pressure drops and the vent opens again.